Hello, my dear students. Welcome to IKSR chemistry classes. In this video, we will discuss the derivation of ground state term symbol for transition metal ions of 3D series. It is important in the study of electronic spectra of transition metal complexes. The lowest possible electronic energy state of an atom or ion is represented by the ground state term symbol, which may be abbreviated as GSTS, and it is expressed in the following form. The lowest possible electronic state of an atom or ion is represented by its ground state term symbol, and it is expressed in the following form: 2s plus 1 Lj. Here S is resultant spin angular momentum quantum number, and it is simply number of unpaired electrons divided by 2. 2s plus 1 is called a spin multiplicity of the electronic state. L is resultant orbital angular momentum quantum number. Resultant orbital angular momentum quantum number. And J is total inner angular momentum quantum number. This is the representation of ground state electronic state of any atom or ion. The value of L determines the spectroscopic state, while 2s plus 1 determines its spin multiplicity. The value of L may be 0, 1, 2, 3, 4, 5, 6, 7 and so on. It is a whole number. If the value of L is 0, the spectroscopic state of atom or ion is S, and similarly, the spectroscopic state of atom or ion may be P, D, F, G, H, I, K, not J, because J is another quantum number, and in order to avoid any type of confusion, the spectroscopic state is written K for L equals to 7. Number of unpaired electrons N may be 0, 1, 2, 3, 4 and so on, and capital S is equal to number of unpaired electrons divided by 2. On dividing 0 by 2, it is 0, 1 by 2, 2 by 2 is equal to 1, 3 by 2 and 4 by 2 is equal to 2. These are the values of capital S, that is resultant spin angular momentum quantum number. And on putting the value of S in the term 2s plus 1, we get a spin multiplicity value which is equal to 1, 2, 3, 4, 5 and so on. And these spin states are called, if 2s plus 1 is equal to 1, the spin state of the spectroscopic state is singlet, 2 for doublet, 3 for triplet, 4 for quartet and 5 for quintet. Singlet, doublet, triplet, quartet and quintet, these are spin states of the spectroscopic states. And now Hund's rule. Hund proposed a set of 3 rules to determine the ground state electronic energy level for various atoms and ions as follows. For a given electronic configuration, the term having maximum spin multiplicity, that is maximum value of 2s plus 1, has the lowest energy. If various electronic arrangements are written for a given electronic configuration of an atom or ion, the term having maximum spin multiplicity has the lowest energy. This is due to exchange energy, which is a matter of much explanation, and it will be discussed in any other video. If two or more terms have the same spin multiplicity, the term having highest value of L has the minimum energy. If two or more terms have the same value of spin multiplicity, the term having highest value of L has the minimum energy. And for the value of J, the highest value of J is selected if the subcell is more than half filled, and the lowest value of J is selected if the subcell is less than half filled. Calculation of values of L, S and J for the ground state term symbol from the most stable electronic configuration of the atom or ion. L, capital L, that is resultant orbital angular momentum quantum number, is equal to the summation of ml values of all the electrons, where ml is magnetic orbital quantum number. S is equal to, capital S is equal to summation of ms values of all the electrons, where ms is the magnetic spin quantum number, and it is equal to n by 2, that is number of unpaired electrons divided by 2. And J, the value of capital J varies from L plus S to L minus S in integral steps. It is called Claves-Jordan series. Ground state term symbol for Ti triple plus ion having electronic configuration 3d1. This is the valence shell electronic configuration of titanium atom, and accordingly the electronic configuration of Ti triple plus will be 3d1. There is one electron in the 3d subcell. Capital L is equal to summation of ml values, and this electron is present in the first box having ml equals to plus 2, and therefore capital L is equal to 2, and it corresponds to a spectroscopic state D. Capital S is equal to summation of ms values. The value of ms for this electron is equal to plus half, that is 1 by 2. On putting this value in 2s plus 1, it comes to be 2, and its spin state is doublet, while a spectroscopic state is D. The value of J varies from L plus S to L minus S, L 2 plus S 1 by 2, it is equal to 5 by 2, and L minus S 2 minus half, it is equal to 3 by 2. There are two values of J, 5 by 2 and 3 by 2. Ground state term symbol for titanium triple plus ion, it is a spin multiplicity 2s plus 1 and it is equal to 2. D state for L equals to 2, and since the subcell is less than half filled, the lowest value of J will be selected for the ground state and it is doublet D 3 by 2. It can be simply written as doublet D. Now the ground state term symbol for vanadium triple plus ion. It is the valence shell electronic configuration of vanadium triple plus ion. There are 2 electrons in the D subcell. Capital L is equal to summation of ml values. The first electron has ml equals to 2 plus 2 and the second electron has ml equals to plus 1, and therefore capital L is equal to 3 and it corresponds to F state. Capital S is equal to summation of ms values plus half, it will be equal to 1, and 2s plus 1 is equal to 3. It is triplet state. The value of J, maximum value of J is L plus S, that is 4, and its minimum value is 3 minus 1, that is 2, and the value of J varies from L plus S to L minus S in integral steps. Thus, there are 3 values of J, 4, 3 and 2. The ground state term symbol for vanadium triple plus ion will be triplet F2. The lowest value of J will be selected for the ground state term symbol because the subcell is less than half filled. Thus, the ground state term symbol for vanadium triple plus ion is doublet F2, which can be simply pronounced as not doublet F2 not. It is triplet F2 and it can be simply written as triplet F. The same process can be performed for the determination of ground state term symbols of other transition metal ions. Chromium triple plus ion has electronic configuration 3d3. There are 3 electrons in the D subcell. Capital L plus 2 plus 1 plus 0, it is equal to 3, F state. Capital S plus half plus half plus half, it is equal to 3 by 2, 2s plus 1, that is a spin multiplicity. On putting this value 3 by 2 in 2s plus 1, we get a spin multiplicity 4. It is quartet spin state. The value of J varies from L plus S to L minus S. 3 plus 3 by 2, it is equal to 9 by 2, and the minimum value 3 minus 3 by 2, it is 3 by 2, and the value of J varies from L plus S to L minus S in integral steps, and there are 4 values of J: 9 by 2, 7 by 2, 5 by 2 and 3 by 2. The ground state term symbol for chromium triple plus ion will be quartet F 3 by 2. Still, the subcell is less than half filled and therefore minimum value of J will be selected for the ground state term symbol. Its ground state term symbol is quartet F 3 by 2, which can be simply represented as quartet F. Ground state term symbol for chromium 2 plus ion having valence shell electronic configuration 3d4. Capital L will be equal to summation of ml values plus 2 plus 1 plus 0 minus 1, and it is equal to 2. It corresponds to D state. Capital S summation of ms values plus half plus half plus half and plus half, it will be equal to 2. 2s plus 1 will be equal to 5. The spin state is quintet. the value of j varies from L plus S, that is 4, to 2 minus 2, that is 0. The value of j will be 4, 3, 2, 1, 0. Please note it again that the value of j varies from L plus S to L minus S in integral steps. The ground state term symbol for chromium 2 plus ion having 3d4 electronic configuration will be quintet D0. 3d4 is still less than half filled, and hence the minimum value of j will be selected for the ground state term symbol, and the ground state term symbol for chromium double plus ion is quintet D. And now the ground state term symbol for Mn2 plus ion having 3d5 electronic configuration in the valence shell. There are 5 electrons in 3d subshell and it is half filled. Capital L is equal to summation of ml values, and these values are plus 2, plus 1, 0, minus 1 and minus 2, and the value of capital L is equal to 0. It is S state. Capital S is equal to summation of ms values of all the 5 electrons plus half, plus half, plus half, plus half, that is 5 by 2. 2s plus 1 will be equal to 6. The spin state is sextet. Capital J has only one value in this case because L is equal to 0. L plus S and L minus S both will be equal to same mode values, and it is 5 by 2. The ground state term symbol for Mn2 plus ion is sextet S, not D. Sextet S, 5 by 2, and it can be simply written as sextet S. Ground state term symbol for Fe2 plus ion having 3d6 electronic configuration. Capital L is equal to summation of ml values. These two electrons have ml values plus 2, plus 2. This has plus 1 value, this has 0 value, minus 1 and minus 2. On solving it, we get capital L is equals to 2, and it is nothing but D state. Capital S is equal to number of unpaired electrons divided by 2. There are 4 unpaired electrons, and capital S is equal to 2. 2s plus 1 will be equal to 5. It is quintet spin state. Capital J has maximum value L plus S, that is 4, and minimum value L minus S, that is 0, and these values of J will be 4, 3, 2, 1 and 0, and the ground state term symbol for Fe2 plus ion will be quintet D4. Here the subshell is more than half filled, and therefore the maximum value of J will be selected for the ground state term symbol. And now the ground state term symbol for CO, cobalt 2 plus ion having 3d7 electronic configuration. It is again more than half filled. Capital L is equal to summation of ml values on following the same process: plus 2, plus 2, plus 1, 0, minus 1 and minus 2. The capital L is equal to 3. It is F state. Capital S is equal to number of unpaired electrons divided by 2. There are 3 unpaired electrons, 1, 2 and 3. It is 3 by 2. 2s plus 1 is equal to 4. It is quartet spin state. J equals to L plus S, 9 by 2, and L minus S, 3 by 2, and the value of J varies from L plus S to L minus S in integral steps, and these values are 9 by 2, 7 by 2, 5 by 2 and 3 by 2. the ground state term symbol for cobalt double plus ion will be quartet F 9 by 2. The maximum value of J will be selected for the ground state term symbol for cobalt double plus ion because 3D subcell is more than half filled. The ground state term symbol for cobalt 2 plus ion can simply be written as quartet F. Now the ground state term symbol for Ni2 plus ion having electronic configuration 3D8. There are 8 electrons in the 3D cell subcell. Capital L is equal to summation of ml values plus 2 plus 2 plus 1 plus 1 0 plus 0 minus 1 and minus 2. On solving it, we get capital L equals to 3. It is F state. Capital S is equal to number of unpaired electrons divided by 2. Number of unpaired electrons is 2. 2 by 2, it is equal to 1. The spin state will be 3. Triplet state. J, the value of J will have maximum value L plus S, that is 4, and minimum value L minus S, 3 minus 1, that is 2. The values of J will be 4, 3 and 2. The ground state term symbol for Ni2 plus ion will be triplet F4. Triplet F4, which can be simply written as triplet F. Here the maximum value of J is selected for the ground state because the subcell is more than half filled. And let us now derive the ground state term symbol for Cu2 plus ion having 3D9 electronic configuration. Capital L on the same basis will be equal to 2. It is D state. Capital S, number of unpaired electrons divided by 2. It is 1 by 2. Max 2s plus 1 will be equal to 2. Doublet spin state. The value of J will be L minus S. The maximum value will be L plus S, 2 plus half, that is 5 by 2, and minimum value will be L minus S, 2 minus half, that is 3 by 2. The ground state term symbol for Cu2 plus ion will be doublet D, 5 by 2. Here also the maximum value of J is selected for the ground state term symbol because the subcell is more than half filled, and its ground state term symbol, that is the ground state term symbol for Cu2 plus ion, is doublet D. And finally, the derivation of ground state term symbol for Zn2 plus ion having 3D10 electronic configuration. 3D subcell is fulfilled here. Capital L is equal to summation of ml values, and on solving these values we get capital L is equals to 0 and it is S state. Capital S is equal to number of unpaired electrons divided by 2. There is no unpaired electron, 0 by 2, it is 0. Capital L is 0, capital S is also equal to 0. Spin state will be 1, it is singlet state. There will be only one value of J because both L and S are 0. The value of J is equal to 0, and the ground state term symbol for Zn2 plus ion will be singlet S0. That is singlet S. Thus, we have derived the ground state term symbol for transition metal ions of 3D series. And let us summarize the findings in the previous discussion. These are various transition metal ions of 3D series having electronic configurations from 3D1 to 3D10. These are the values of capital L calculated earlier. Number of unpaired electrons increases from 1, 2, 3, 4 and 5, and then it decreases due to pairing up of electrons 4, 3, 2, 1 and 0. Capital S is equal to number of unpaired electrons divided by 2, and these values are given here. 2s plus 1 increases from 2, 3, 4, 5, 6 and then decreases. These are the values of capital J when the subcell is less than half filled. Minimum value of J is selected, that is L minus S. And when the subcell is more than half filled, maximum value of J is selected for the ground state term symbol L plus S. These values, this is 2, L is equals to 3 and S is equals to 1. The maximum value of J will be 4 for the ground state term symbol because the subcell is more than half filled, and these are given the ground state term symbols for various transition metal ions of 3D series. Thank you for watching the video with concentration. We will meet shortly with another video. Thank you again.